My name is James Kirkham. I'm a senior data engineer at CFA Institute in Charlottesville, Virginia. My most recent position is senior data engineer at CFA Institute. CFA Institute is in the business of creating and delivering exams for financial analysts. We have recently transitioned probably close to or above 90% of all of our IT infrastructure into Azure. That includes front-end things customers access and whatnot, and all of our back-end databases are, most all of them are Azure PaaS, Platform as a Service databases. We still have some on-premises stuff, but not very much at all anymore. I do a lot of work in Data Factory, pipelining data around, moving data from our operational systems into our data lake, and preparing our new data lake. My primary area of focus is the integration with our testing vendor, who actually delivers our exams for us to our candidates, and then moving that data back into our side of the house, enriching it, creating a grading platform for our psychometricians to evaluate candidate responses sort of on a mass scale, grade the exam, come up with minimum passing scores, and other statistics about how people performed on the exam, both individually and overall. And then integrating exam outcomes and other data into our data lake, and then creating both operational reporting, BI reporting, type reporting, so that the business can leverage that for their needs. We're also creating what we call Data Lake 2.0. We're sort of in the midst of that. We're trying to transition our data lake to be as file-based as possible from being primarily centered around traditional relational storage. We're trying to move our data lake into file-based storage, sort of both at the raw level and also the intermediate level. We want to keep everything, or transition from schema on write to schema on read, essentially, in a nutshell, so that we either don't write data to a schema until we absolutely need to, or we virtualize that schema as much as possible. And that's sort of what I'm going to be focusing on. Yeah, I'm most familiar with Kimball methodology, so designing a data warehouse around business processes pretty strictly. So in the process, you sort of, determine the grain of your fact. You determine the dimensions that affect that, what's joined to from your fact table, right? Your dimensional tables. I've just designed at a previous position, not my current one. I helped design a couple of different data warehouses. I was the lead on sort of one of those, and then sort of worked as a junior lead or engineer type position on another one. I don't get too much chance to apply sort of star schema type normal architecture in my current job, because we're sort of focused on creating an actual data lake and not generating schemas until we get as close to the users as possible. We find that a lot of our time is spent debugging schema on write, so we want to sort of move away from that and go to schema on read. So we do have plans, however, when we do actually start to MAR data or warehouse it, we are going to use star schemas, sort of like with a traditional Kimball methodology would ask for. That's sort of how I've applied them in the past, and how we plan on applying it. Our typical relational Azure Data Factory ETL process, we generally will have lookup activities that we need to determine any watermarking. We don't have a lot of watermarking right now because we heavily use SQL temporal tables in a lot of our systems. So we use the the valid from, valid to dates, or whether something's in the current table or the history table, to sort of impute a lot of logic, I guess, that we would otherwise use a watermark table for. But anyway, we would sort of start with that. Then traditionally we'll have copy activities. We try to modularize our pipelines as much as possible rather than having one big one. We have small ones called by a master maybe that are triggered by a master. So we have maybe one or two at most copy activities per pipeline. And then if we're not writing to, say, a temporal table, or even if we are writing to a temporal table, most of the time we'll have a merge activity that's just a stored procedure that's called by the pipeline in the database. And depending on what the business need is or the technical requirement, we have the merge procedure will function in a variety of ways depending on what's asked for. That is typically it. We usually copy to an incremental table. We merge the incremental table into the main table, etc. Pretty typical stuff. We also use some data flows, Azure data flows, and we're doing a few things in Databricks, and those are called by kind of separate activities, but they kind of work the same way. Our integration runtimes are usually auto-resolved because we sort of usually we're writing from an Azure database into an Azure database, so we sort of use the default for that. We have a few on-premises databases that we have integration runtime set up for, where we have, things are kind of whitelisted into our side of the house. That's more handled by our network and like our LAN services team than our data team. So we use those to, get into the database, get the data out, on the on-prem side, and then put that data up in the Azure so it can be, we can use it in a copy activity or a merge procedure. As far as enumerating all the different storage types, there's a whole lot. Typically, we use some table storage. We make heavy use of just sort of traditional blob storage. We store a lot of semi-structured data in blob storage, and we end up reading a lot of containers in blob storage. We also use some Gen 2 data lake storage. We're starting to use that more and more as we start bringing what we call Data Lake 2.0 online. That we found that performs a lot faster than traditional blob storage, which it's supposed to, so that's good. I think that's about all I'm really familiar with at this point. I know there's some other kinds of storage in Azure, but I'm not too well versed in the other kinds, I would say. I sort of think of serverless computing as using containers or microservices to accomplish things that traditionally, like in the old days, I guess you could call it, you would have a server accomplish, whether it'd be an NT server or a Unix server, some process that listens for events or connections or what have you. In Azure, I guess you could say, like, I know in my experience, my company has a lot of microservices that run on, that are basically Azure functions that do specific things. Our development teams, the people who work in .NET, they're very disciplined as far as maintaining those services separately so that they have a very strict sort of separation of concerns. So when I think of serverless computing, I think of that using the cloud to have lots of services that do very specific things, rather than having big processes that do lots of different. When I'm not in the office, I really enjoy fishing. I'm getting excited about the springs here, right? So fishing's about to get hot again. So I do a lot of inshore fishing in saltwater over in Tidewater, Virginia, near the Chesapeake Bay. I spend a lot of my weekends in the spring and summer over there doing that. I also play bass guitar. I've started doing that sort of recently. I have a background in normal guitar, but I started thinking I wanted to get back into music again as a hobby, so I'm playing bass guitar now. So when I'm not in the home office, I'm trying to pick that up, learn the bass, and fish, really. Spending time with my family, stuff like that. Yes, I confirm you may use this video for hiring and evaluation purposes.